So welcome to the second video on Chapter 5. This begins with 5.3, which is SAS similarity. So what SAS similarity is? Side, angle, side similarity. And what this tells us is if we have two sides of a triangle, and then we have two sides of another triangle. If the ratios of this side over this side, so if we have these two triangles, if AC over AB is equal to DE over DF, and the angle in between those two lines, so the angle in between DE and DF, right here, angle D, and then the angle in between AC and AB, right here, angle A. So if we have the ratio of AC over AB, if that ratio right there is the same as the ratio of DE over DF, and the angle in between those two lines on each triangle is equal, then you have the two triangles are similar. So let's say that this is 2, this is 3, and this is 4, and this is, let's say, 6 there. And so you have that this is equal to 60 degrees, and that's equal to 60 degrees. So with SAS similarity, you would go, okay, 2 over 3 is equal to 4 over 6. And because this is 4 over 6 is equal to 2 over 3, and the angle in between is 60 degrees, these two triangles are going to be similar because of SAS similarity. So that's how you would use it, and now I'm going to show you how to use it in a problem, and I'm going to go over problem 5.10 that's in your book. Now I have 5.10 drawn up here, and so it gives you AC 4, CD 5, and AB 6. And so it wants you to, in this shape right here, it wants you to find what BC is. So they want you to find what this length is right there. And it says that the perimeter of triangle BCD is equal to 20. So the way we're going to do this is you go AC over AB is equal to 4 over 6, because you see AC is 4 and AB is 6. And then you can simplify that down to AC over AB is equal to 2 over 3. Then you go AB over AD is equal to 6 over 9, which is equal to 2 over 3. If you simplify 6 over 9 down. So because we did this, and the angle in between, so you have AC, so the ratios are good, and the angle in between is just equal to itself because it's the same angle, so it has to be equal to itself. You have that triangle ACB is similar to triangle ABD. And that's by side, angle, side similarity. Now the problem's asking you to find BC, and the way we're going to go about that is to get the length BD in terms of how much BC. So we write this as BD over BC is equal to 3 over 2, because that's the ratio of what their sides are. So then you just cross multiply, so 2 times BD and 3 times BC, so it's going to be 2 BD is equal to 3 BC. And you just divide by 2, and you get BD is equal to 3 BC over 2. So now you have BD in terms of BC. So they give you the perimeter of 20 here, and that's of triangle BCD, so right here. So the perimeter of 20 is equal to 5, which is CD, plus BC, plus BD, but we already figured out what BD is in terms of BC, so 3 BC over 2. Now we can just take out 5 on both sides, so 15 is equal to BC plus 3 BC over 2. Now we just multiply everything by 2, So 30 is equal to 2 BC plus 3 BC. So 5 BC is equal to 30. Just divide by 5. PC is equal to 6. And that's your answer. And that's how you can use similar triangles to get the ratio of their sides, and then you can do all these steps. And so that's why side angle side is important. And now I'm going to move on to 3.4. So let's move on here to 5.4, which is side 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 similarity. So side 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 similarity is S similarity, which is the way it's written in your book. So side side side. Now, what side 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 similarity tells us is that if we have each side of one triangle, so if we had all the sides of this one triangle right here, and they're the same constant multiple of corresponding sides of this triangle right here, then we can say the two triangles are similar. And that's by side 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 similarity. And also, therefore, if the two triangles are similar, then the corresponding angles are also equal. So let's just say that this is right there is 4. This is 5. This is 7. It may not look like it, but those are what the side lengths are. So for this, it's going to be 10, 14, and 8. Now if we put all these sides into a ratio, we have 5 over 10, which is equal to 4 over 8, which is equal to 7 over 14. So when each side of one triangle has the same constant multiple of another triangle's sides, then we can basically say that they all have the same ratio, so this is all going to be 1 over 2. And so by definition, this makes these two triangles similar, so we can say that triangle A, B, C is similar to triangle D, F, E. And so because they're similar, all the angles on the inside are equal, and so that's what side 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 similarity is. Now this is one of the problems for 5.4, and so this is problem number 5.11. And so what they're asking us to prove is that they want us to prove that AE is parallel to BC and AB is parallel to ED. So the way we do this is by using similar triangles. So we say AB over DE is equal to AC over AD, which is equal to BC over AE. If you plug all these numbers in, you get that all these ratios are equal to 1 over 2. So because of this, we get that triangle ABC is similar to triangle DEA because of side 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 similarity. So therefore, angle BAC is equal to angle EDA because they're corresponding angles, and when you have similar triangles, corresponding angles are equal. It's only the side lengths that would be different in similar triangles. The angles are going to be equal for corresponding angles of similar triangles. So because we have this right here, it proves that AB is parallel DE. So that's how we get how AB is parallel to DE, by proving that angle BAC is equal to angle EDA. It not only asks to prove that these two lines are parallel, but also AE and BC. So we just go, okay, so it's the same thing. Because we have similar triangles, angle DAE is equal to angle ACB. And because of that, you get AE is parallel to BC. And so by proving that these two triangles are similar, you can use that to prove that these angles are equal, and so that proves that these two lines are parallel and these two lines are parallel. So that's one of the ways you could use side similarity in one of these situations. And now I'm gonna move on to in the next video to 5.5.